Hi, we're TeslaSenti. Our app helps traders monitor tweets with significant sentiment about Tesla. We are a team of two. Vikram Kate is currently a postdoctoral research fellow at U of T, and my name is Zoe Liu. I'm currently a master's student at MIE department at U of T. Tesla is one of the most discussed and most influential companies in the world today, and its co-founder and CEO, Elon Musk, whose tweet 2 months ago wiped out $14 billion of the company's value, is one of the most controversial figures on social media. We intend to develop a product to identify tweets with strong sentiments that are influential with large amounts of retweets and replies. This product ideally processes live-stream tweets and thus provides guidance for high-frequency traders. In this demo, our project is currently looking at tweets with strong sentiments in an almost real-time setting and display them on an UI. We will explain this almost real-time solution later. There is some evidence to show that sentiment on social media influences stock price. There is a sizable body of research literature dealing with this topic. In particular, it has been found by researchers that sentiments expressed by the Twitterati has some impact on various aspects of stock trading, including prices. We learned that there exists a significant dependence between the Twitter sentiment and abnormal returns during the peaks of Twitter volume. This is valid not only for the expected Twitter volume peaks, for example, quarterly announcements, but also for peaks corresponding to less obvious events. Plus, we need to train our sentiment classifier with financial data because of the unique financial terminologies. Now, let's take a look at our baseline model. For training the model, we gathered the following dataset. We have a Kaggle dataset named as the Financial Phrase Bank dataset, which contains nearly 5,000 financial news headlines. We also obtained relevant tweets and headlines from Fika, which is the financial opinion mining and question answering dataset. The obtained labels are positive, negative, and neutral. For this project, we combined the positive and negative ones and put them into a class as non-neutral. Now let's take a look at our baseline model. We trained our baseline model with naive Bayes using the NLTK count vectorizer. We achieved around 87% accuracy on train set and 75% accuracy on test set. For the alternative model, we tried Bert, which stands for Bidirectional Encoder Representations for Transformers. To be specific, we implemented this Bert for sequence classification Hugging Face transformer. Using only the Financial Phrase Bank dataset and a stratified train test split, we achieved an 89% accuracy on train set and around 87% accuracy on test set, which is much improvement compared to the baseline model. Here's our final solution. Twitter streaming API is used to fetch tweets about Tesla in real time. Retweets and replies are filtered out. Tweets with profane language are filtered out. Too many cash tags are filtered out because we find that a big fraction of tweets with too many cash tags are advertisements of financial services. Emojis, smileys are removed. Mentions and hashtags are removed. Tweets are tokenized and stamped using NLTK. The trained naive Bayes model is used to predict the label of each tweet. The probability outputted by the model is used to eliminate weak sentiment tweets. Only those tweets with probability larger than 0.8 are shortlisted. And here is our deployment. The naive Bayes model is deployed locally. Since streaming is involved, we used Python multiprocessing package and implemented 3 processes. Process 1 continuously appends real-time tweets and other details like publish time, number of retweets, screen name of users, etc. into a single file. Process 2 continuously reads this single file from Process 1 and generates separate files with tweets from 30-minute intervals. Apart from that, Process 2 also cleans the tweets, runs the naive Bayes model, and picks the top most sentimental tweets. The file name contained the upper and lower bounds of the time interval. Process 3 continuously looks at the file names dumped by Process 2, takes in the latest file, and in this way showing the users the latest tweets. Here's our GitHub repo and our references. Now, Vic is going to walk us through the demo.
This app is useful to someone who is interested in following tweets about Tesla in near real time. This user could be a trader, an investor, or an amateur who is interested in Tesla. The user interface shows 4 tweets at a time. These tweets are from within the last 30 minutes. Each of these tweets could be expressing a positive sentiment about Tesla or a negative sentiment about Tesla. Since in the past few days, the Tesla stock has been doing very well, today's tweets are dominated by discussion about Tesla's stock. And the theme mostly is that Tesla stock is increasing rapidly. As you can see, this tweet is not directly about Tesla, but it is about Rivian, which is another EV who is competing with Tesla. So if the user wants to look up at the original tweet, he or she can click on the tweet and it takes it to the original tweet. And in turn from here, the user can go to the original news article if he or she is interested in reading the whole article. User clicks on the update button. Then the next 4 tweets are fetched and displayed on the UI. Again, these can be from different topics related to Tesla. At any given time, the tweets displayed are within the last 30 minutes.